Okay, so we're gonna start out trying to explain this thing called chirality. Okay, and we're gonna start out with a carbon and it has three red atoms attached to it. So this is not a real structure. And what I'm gonna do is I'm gonna have this carbon here, one little circle on it is gonna be different. I mean, it's just gonna maybe be a little different. Okay, and so let's compare these two structures. So now I have this circled red up here and over here, and I ask myself, are these two structures the same? Okay. Now, if you look at them as they're set in the screen, you can see that they're not the same because this guy is on top over here. Okay, it's on top instead of the right. But okay, we're allowed to rotate counterclockwise or clockwise these structures. Okay, and so simply if I just turn this structure counterclockwise, you can see that is the same structure. Okay, all right. So so if I call this maybe if this is special red one, okay, methane. This one is still going to be special red one methane, because now instead of starting one here, one is now on top. Okay, so the thing is that looking at the two structures, they don't look the same when they're placed in each other. Okay, you can't drop this guy on top of this guy over here and to be the same. But actually, you're allowed to, if you're allowed to rotate it counterclockwise and clockwise, you can see to get the same structure. So these two structures are equal. Okay, now how about if we place one of the reds with a blue? Well, it's kind of the same thing. Now instead of having that special red guy over here, I just have a special blue. Okay, and so is this structure, structure one, structure two, and structure three, are they the same? Okay, well, you can see that the blues on the right here, it's on the top here, but if you notice, all I did was I simply turned it counterclockwise, and it's still the same structure. So if I call this one blue, this one is still going to be one blue, and this one's going to be one blue too, because all I did is I either moved it this way or I moved it twice this way. Okay, so if you can move the structure in the plane in two-dimensional structure and move it without having to physically break a bond and do anything else to it, then you got the same structures. All right, next thing. So let's now replace one of the reds with a green. Okay, so so I have my structure here, and let's say I'll call this 1, and I'm going to call this blue 1, green 2, red 3, red 4. Okay, now I want to compare it to this structure here. Are these two structures the same? Well, hopefully you see if I just turn this one clockwise, you'll see that now it's still the blue and the green are right next to each other, and so they look like they are the same. Okay, now how about this guy over here, the bottom one? So we'll call it structure 1, structure 2, and structure 3. Now, is structure 3 equal to 1 and 2? 1 and 2 are the same. Okay, now it doesn't look like it, okay, because now the red and green are next to each other, so it doesn't look like they're. So it looks like this structure is not the same as these two up here. So it doesn't look like 3 is equal to 2 and 1. Okay, But it turns out that it is, and that's because in this scenario 1 and 2, I simply turned in the plane counterclockwise or counterclockwise. But you got to remember that this structure here is three-dimensional, and if you remember, it's tetrahedral, so it looks like a tripod. Here's your tripod, and here's the stick coming off of it. So this might be a red here, a blue here, green here, and red here. Okay, and so it turns out that you're not only allowed to rotate in the plane counterclockwise or clockwise, you're actually allowed to move in and out of the plane. And so when I go up, maybe that means I'm pushing the structure into the plane, and when I go down, out of the plane. Okay, so it turns out that if I take this guy and I turn it three-dimensionally, it will be exactly the same structure as this. Now, it's hard to see that in 2 dimensions. Okay, excuse me. But you'll have to believe me with that, all right? Now, what our goal is this. This is by looking at a structure, looking at the bonding of a structure, how can I figure out what it looks like in 3 dimensions? Okay, so how do I know that this guy here is equal to this guy over here when they don't look alike in 2 dimensions because of green and blue? All right, so and that's going to be the next step. All right. So all three of these structures are the same. And here's an example. Here's the same thing. I just simply uh, are these. So is this guy here the same as this guy here? And it turns out, yes, it is. Okay, even though the red and green are opposite sides of each other. All right, and it does it. So it looks like I can't. It doesn't look like I can turn this clockwise or counterclockwise to get this blue over here. But if it's 3 dimensions, you actually can do that. Okay. All right. Now to the next one. And I'm going to put this all together, and so that hopefully you'll be able to, just by looking at the structure, you'll be that how it's bonded. You'll be able to tell that this structure here is the same as this one here. Okay, so the last example is this guy here. And now I'm going to just have one red and a blue, green, and orange. Okay, and simply if I wanted to, I could, if I had this structure here where the red's down here, red, and the orange is up here now. Orange, red, blue, green, you could simply see that I turn this clockwise to get to these two structures. These two structures are exactly the same because I could turn them and twist them. Now, how about this structure over here? Okay, so it looks like I have the orange and the blue are opposite from each other, and from the last one, I said I had a green over here and switch, and I said they'd be the same. But now what I have is I have a red and a green opposite each other. Okay, so are these two structures the same? Okay, so this carbon here has 4 different types of atoms or types of atoms attached to it. Okay, while the other ones didn't have 4 different types. They only would have 1 or 2 different, or 3 one or two are different. Okay, so And that's going to be key here. So it turns out, no matter how hard I try, turn it clockwise or counterclockwise, into screen and in, out, like just like this, or into the plane and out of plane, these two structures are not the same. Okay. So this guy here, it will have to have a different name. I might want to call it left orange, right blue. And this guy here is going to be the other ways around, left blue and right orange. So these two structures are not the same. Okay. You can't rotate this structure any way you want into getting this guy over here. You just can't. These are not equal. All right. The only way you can make this structure over here, okay, is to actually physically break a bond to get it. Okay, and you're not allowed to do that if they're the same structures. All right, so let's put it all together now. All right, so let's put it all together. So I have 4 different examples here, all the same, attached to carbon, 1 different attached, 2 different attached, and 4 different attached. Okay, so so we found in the first example is that you could rotate this guy no matter. So if I had the special carbon here 1, then simply if I moved over here, same be the same structure. For this guy here, if I had this blue out here and moved it here, it's still going to be the same structure because I can rotate it. So structure 1, structure 2, structure 3, we learned is that even so that this, it doesn't matter if the green or the blue, or if the green is here, or the blue is over here, or if the green is up here. They're all, this is, no matter where the green is and the blue is, it's still going to be the same structure. So if this was like green, red, blue, red, so even though it doesn't look like I can twist it and turn it in this inside the screen, we know 3-dimensionally you can turn it to get the same thing. And then this guy over here, the 4th example, where he had 4 different things attached to this center carbon, is that there is a difference between this guy here and this guy here. They are not equal. Okay. So what I want to do is, just by looking at my structure, okay, looking at how it's bonded, I want to know is if I twist it, or if where this blue, if I put the blue over here, okay, if I put it over here or up here or here, how do I know that it's the same structure? Okay, 3-dimensionally, same thing. How do I know that it doesn't matter where I put the blue, up here or up here, it's still going to be have the same name? And how do I know that these 2 guys are different? Well, here's the key. All right, is notice is that this guy over here, the bottom one, has 4 different things attached to this carbon here. If these carbon has 4 different things attached to it, it can have another structure that is not the same, that has the same kind of bonding. Okay. Now, if it has the same, now these guys up here, doesn't matter how you draw them, they're always going to be the same. Notice is that they don't have the same things attached. So they have, there's always at least one other thing that's the same attached. So they don't have all different things attached. This has all reds. This has 3 reds. This has 2 reds. Okay. So if it has at least two of the same things, doesn't matter how you twist or turn or draw it, it's going to get the same structure. But if it has all different things attached to it, it does make a difference. And when you draw the bonding structure, they are two different structures, and so you have to name it. Okay, so this guy here, so these two structures are different. Okay, so next thing is to apply this to our chemistry, our carbohydrates. Okay, so now let's apply this to what we're going to use it for in this class in the big picture. Okay, so this is glyceraldehyde. Okay, it actually kind of has three parts to it. There's three carbons. Each one of the carbons has an OH hydroxyl off of it. Okay, and the center one has, instead of two hydrogens attached, it has a hydrogen and group 1. We'll call this group 1, 2, and 3. And so it has group 1 and group 3 attached to it. Okay, so what we want to do is compare these two structures. This is also glyceraldehyde over here. And you'll notice the only thing that's different about structure A and structure B is that I move this OH in structure A to over here, and then now it's on the left side. And so what I want to do is I want to know if these two structures are the same. Okay, it doesn't matter that I switch it over here to the left or the right side. Okay, so what we do is, so actually what we want to do is kind of do it for all the structures. It doesn't matter that this OH is here or over here. Okay, so let's take a look at that before we go over A and B. So it doesn't matter that this OH is attached to the left or the right side. Okay, so if I move the OH over on the other side, the H will be over here on the right. So now the key thing to know is if this doesn't matter or not, whether I draw the OH on the right or left, is that if this carbon has 4 different things attached to it, then it does matter. Okay, so let's look. So this carbon here has this OH attached to it, has H and an H, and then has this group 2 attached to it. So no, it doesn't have 4 different things attached to it. It has these two H's the same, so it only has 3 different things attached. It has H and OH and this thing down here. So it doesn't matter where I put the OH, okay? All right, so this structure down here doesn't matter if I move the OH to the right or left. Okay, now, so what you want to do is that you see up here is group 1, group 2, and so it has group 1 attached, group 2 attached to it, and it has H and OH. So it looks like it has 4 different things attached, because this group A and group 1 and group 2 look the same, different, and and it has H and OH, and so it does look like it's important to that these two structures are not alike. Okay, but if you look at the 1 and 3, you can see that these two structures, number 1 and number 2, are the same. They both have, the carbon has 2 H's attached to it and an OH. Okay, so both of them. So these two groups are the same. So does this carbon have 4 different things attached to it? No. Group 1 and group 2 are the same. All right. And so these two structures doesn't matter. They're on if this OH is on the left or right. So you have to, so don't just, even though these number 1 and number 2 look the same, and you look at the whole picture, the whole group that's attached to this carbon. So this carbon has this thing attached, this thing attached, which are the same. They're exactly the same, okay? And as the OH and H. So it has two same things and two different things. So yes, these two structures are exactly the same. So it doesn't matter. So the glyceraldehyde doesn't matter at all if you put any of the OHs anywhere. So if you could take this OH and put it on top here. You could draw it with OH sticking out the top. You can have or you can have the OH over here and OH over here and OH over here. It still be the same. It doesn't matter how you draw the structure at all, as long as it's that each carbon has the OH and the appropriate things. Okay, and so there is no difference in how you draw the structures here. They're all going to be the same. All right, so now we're going to go to the next one. Okay, next up, what I'm going to do now. So this is glyceraldehyde. This is glycerol. So this is glycerol. And we learned this in the last talk about not fatty acid. But this is glycerol. This is an alcohol. Just talk about it. It has 3 hydroxyls attached to it. And it doesn't matter where you put the OHs. It's always gonna, no matter how you draw it, you can always get the structure. Now what we're gonna do is we're gonna change this by oxidizing it, and we went over that. So what you're able to do is you get rid of hydrogens, 2 hydrogens, and you end up getting this structure over here, which is called glyceraldehyde. Okay, look it up how to spell it. Okay, so we did that. So now I want to look at this structure here and see. Doesn't matter how I draw it. Doesn't matter where I draw these, where I draw the OHs and everything else. Okay, so that's going to be the next slide. So we have two drawings of the glyceraldehyde. I did some bad chemistry here. This H shouldn't be here because carbon only could have 4 bonds. So remember, this is an aldehyde. So each carbon has 4 bonds. 1, 2, 3, 4. So okay, so now let's look at we're going to look at this. So let's 1, 2, 3, and there's A and B again. Okay. All right. So all of them have a 1, 2, and 3 component. The difference is that in the number 2, then the number 2 component is this. We swap the OH, and so it doesn't make a difference. All right. So we're going to look at this carbon here and see if it has the same. If it has 4 different things attached to it, and then it does make a difference, and these two structures are different. Before we do that, let's go through the top carbon and the bottom carbon and let's see if it matters how we draw it. So if I take this O here and I put it over at the H, doesn't make a difference. Well, the thing is does this carbon have 4 different things attached to it? If it doesn't have 4 different things attached to it, then that doesn't matter how you draw it. You put the O over here on top. So does this carbon have 4 different things attached to it? Well, it only has 3 things attached to it. It has the oxygen, hydrogen, and number 2. So it doesn't matter how you draw this. All right. So the bottom one. Doesn't matter if I put the OH here, here, or here. Okay. So if this carbon here has 4 different things attached to it, then it does make a difference. Okay, where we put that OH and whether it's a different structure. And you'll notice is that it has an OH, but it has two hydrogens attached. So it doesn't matter where you put this OH. So the top and bottom one, these are what we call achiral, which means it doesn't matter how we draw them. They'll always be the same. In a sense, we say is that they don't have a mirror image. Okay, so now let's look at the center carbon here. So does this carbon here have the same things, 4 different things attached to it? Okay, so as an H, an OH, this structure and this structure. Okay, all right. Okay, so it actually has 4 different things attached to it. Okay, in the previous example, number 1 and number 2 were the same, but here you see that number 1 and number 3 are the same. So it does make a difference where you put this OH here. Okay, so if you put it here on the right or on the left, okay, that does make a difference. So these 2 structures are not the same. And that's because it had this carbon here has 4 different things attached to it. Right. So we'd have to name this guy. So this guy here, and we're going to name it according to where this OH here. So we're going to say this is a right, and for what reasons there is D stands for right. So this would be a D-glyceride, glyceraldehyde. And because that OH is to the left, this one is called an L-glyceride. Right? The key thing about all of this is you look at the carbon and you see if it has 4 different things attached to it. If it doesn't, then it's called achiral. If it has 4 different things, the center carbon has a chiral carbon, and it does make a difference in how you put the parts to attach to it. Don't just look at, is this at the carbons, all right? Look at the whole, this is a part, this is a part, this is a part, and this is a part. I hope that helps out, okay? It's a little bit long, but